All right, so good morning. I'm going to do a couple sections here on logarithms, talk about those and their properties, definition, so forth. Then you guys are going to have a quiz over the first two sections, or the first three sections, sorry, the things we did last week. Also have a project or an activity paper for you. That's going to be posted on the DTL site also, so you can access it that way. And then that's due on the 25th, which is Memorial Day weekend. So sorry it's due then, but you can always take it and take a picture of it and send it to me via email or something along those lines if you need to do that. So let's talk about logarithms a little bit here. And before we get too much into that, what I'm going to do is go into Desmos, and let me get rid of some things here. So one of the things, what you want to do here is pause this whenever you feel the need to. Don't just let it run. It's going to be not too good if you don't pause it once in a while. Make sure you're kind of following along with me. Access Desmos, do some things. Ask some questions so that you're understanding what we're doing here, and then just make sure you just tell the substitute, hey, can you pause it? Just don't let it continually run, so you're getting everything out of it. It's not an ideal situation, but it's the best I can do, and since I'm on my way to Neoconi at this time. So let's do this. I got myself a Desmos graph. And what I'm going to do is add a table. So, whoops, let me get back to hit the plus here. I'm going to add a table. And what I'm going to do is I'm going to start with a 0. And then I'm going to put a 0.1 down here. And go over to the next one will be 0.2. And if I just hit enter, Desmos knows that that's what I want to do. I want to continue this all the way down to 1. There we go. And then for my y values, once I have from 0 to 1 by 0.1s, I'm going to come up here to the top. And I don't want the y1 there, so I'm going to delete that. And I'm going to put 10 to the x1. So I'm just going to go x and 1. It knows that it's a subscript that's over on the other side. So it relates that. Gives me this nice graph here. All right, it's kind of what I want. I think what I'll do is actually change the window a little bit. There we go. Okay, so basically I just went from 0 to about 1.5 on the x-axis and 0 to 15 on the y-axis, just so I could get a little bit better curve. There we go. So this is an exponential curve. That's what we talked about last week. All right, so if I wanted to, I could go y equals 10 to the x, and ta-da, there it is. So there's my exponential curve. 10 to the x. All right. Now, what we're going to do is I'm going to add another table, and I'm going to tie in one of the other ideas from last week, and that's the whole idea behind an inverse. And when we talked about an inverse last week, we said that the domain and the range switch. So we're going to take the x values and the y values in this table up above, and I'm going to switch them, and then I'm going to put them in a new table. So I'm going to go to plus, add a table right here, all right, and then I'm going to put the y values into the x. So I have 1 there, and then here I'm going to go 1.25, then I'm going to go 1.58, and I'm going to keep doing this all the way down Let me go get my glasses here so I can see a little better. $2.51, 3.16, and let's see, gotta move this down a little bit more. 3.98, 5.01, 6.3, 7.9, and 10. Then we know what we're going to have here is 0.1. Now, unfortunately, it won't guess on the y's because those are dependent values, so it doesn't get that part that we want to do the same thing. So I'm just going to put them in myself. Now let's see what we get for a graph here. Okay, so now that I have this graph, I might have to change my window again, right? Because obviously I'm going to get different things. So first of all, let me turn off this. I don't really want that on. And go back into here. So now, again, I'll make my x-axis. Let's go like a negative 0.5. And let's go to 15. And we want the same thing here. And I can always change this to something else that I want. Okay, so let's see what we got. I like that one pretty well. So that gives me a pretty good view of what these graphs look like. All right, so we're switching the domain and range around. Remember we said this is inverse. The true test here graphically is to graph the line y equals x. When we do that, we can see that the green is a reflection of the black dots. Right? So that means that we have an inverse, right? So if we reflected the black points over that y equals x line, we should get the green. Okay? Because again, we fixed it that way. We set it up because that's an inverse. So a logarithm just happens to be just that thing. All right, so logarithms. So we have a definition of a logarithm. All right, and this is kind of the important thing to get, is this whole idea of a definition of what the logarithm is. So the definition of a logarithm basically is this. We have y equals 10, I should say actually, y equals b to the x. Now b is a base. All right, in our case we had 10 because that's what I did, y equals 10 to the x. All right, the logarithm is going to be this, the log base b of y is equal to x. So the domain and the range are switching. So here's the domain for this. Now that becomes the range for the log. And this is the range. Now that becomes the domain for the log. The base is the base. Okay? That's the definition of a logarithm. So let's play around with some number things here. So let's say we have 2 to the third, and we know that's 8. All right? So that's an exponential equation, exponential representation. If we go to a log, that's going to be the log, and this is going to be my base right here. So that 2 is going to go there. Okay? Then, domain and range switch. So the 8 becomes my input, and that becomes my output. So let's see, 3 to the 5th here, 81, 729. So written as a log, base is b, $7.29 becomes my input because my output over there, 5 goes there. All right, that's the definition of a logarithm, pretty much the way it is. So if we go back to Desmos, all right, and I say, okay, I'm going to go y equals, and I'm going to go down here to log. So I have to push miscellaneous, hit log, put x in there. There it is. All right, so you can see, again, that's going right through those dots. All right, so that's pretty good. So there's my logarithm. There's my definition. Okay, so it's going to ask you to write logs as an exponential. Now you can have the log of any base. Oops. Okay, so you can take the log of any base here that's positive. All right, can't do any fractional stuff. So that base is a positive number. All right, and this here, so we got to figure out, okay, 5 to what power is going to be 625, right? So that's basically what we're doing. So let's see, that's going to be 5 times 5. So 5 to the second is 25, 5 thirds 125, 5 fourths 625. So that'd be a 4. All right, so write logs as an exponential. All right, I want to write it as 5, that's my base, to the 4th equals 625. It's that simple. All right, so you're taking this here, oops, and you're writing it as an exponential. 5's the base, 4th power equals 625. All right, output here becomes the input because they're inverses of each other. Okay, log base 10. I got 4 zeros here, so that's going to be 4. Why? Because 10 to the 4th is equal to this. Again, write it as an exponential. And we'll go backwards. Write as a log. So now they're going to give you this. They're going to say, okay, we have 2 to the 5th is equal to 32. We're going to write that as a log. Well, that's no problem. Log, here's my base, all right? Output becomes input. There we go. The log 32 base 2 is equal to 5, right, as a log. Anytime you have an exponential, you can do that. Log base 3, 27 equals 3. Writing it as an exponential. Okay, they're just inverses of each other, and that's what a logarithm is. A couple other things about logarithms before we get into a little more of them. They're going to talk to you about they're going to ask you some questions about this. Okay, well, that's equal to a log with a base of e. Remember, e was that special number that we had last week. We talked about that. I said, hey, it's going to come up when we do logarithms, and here it is. So when you see an ln like that, that means the base is e. Right, so if we have the natural log, I'm going to pull an example up here. So bear with me for a second. Let's see. ln's right here. So let's go to ln of 5 is 1.609. So what does that mean? Well, that means if I take e to the 1.60943, you can see that I'm getting really, really close to 5. right, which is a number in there. Okay, so all the log base e is just a natural log. That's what they call it, ln. All right, it's called the natural log. And that's how that works. It's not anything big deal, just a natural log. All right. So you're going to see some of those things. You're just going to treat them as the bases are e's. So when you write them in exponent form, it's not a big deal. They are going to ask you about the domain and range of a log function. Let's go back to this. So here's my log function here in red. Okay, and if I trace along, it starts to show you some numbers right about there. And we have 0.0605. Let's see what happens. All of a sudden they kind of disappear. This is going like this here. And it's slowly kind of growing very so casually. So domain-wise, we're not quite sure. Well, it runs along this, but does it ever touch 0? So let's investigate that. So can we do that? Well, that means that I could take the log, say base 10, of 0, and I would get a number, correct? So let's say that number is a, just for the heck of it. Well, that means that 10 to the a power has got to give me 0, because that's the definition of a logarithm, right? Well, I can't think of any 10 to any power. What the heck? So 10 to the, we know 10 to 0 is 1, right? 10 to a decimal is going to get pretty close to 0, but it's never going to quite hit 0. So that means that this here does not work. All right, so on your graph, yes, it's going to get very close to x, very close to 0, x is, sorry, but it's never going to hit 0. Okay, it is going to grow. So the domain of a log function, just a general log function, domain is x has to be greater than 0. The range, though, we're okay. Now, of course, we can transform these, move them around, stretch them. That's going to change the domain. Right? But the main thing is, in a basic form, this number we're taking the log of has to be greater than 0, because it just does not work. So we can't even take the log of a negative number either. Right? Doesn't work. Okay, that's stuff on domains. Pretty straightforward. We want to find an exact value. So they're going to give me a problem like this. All right, so I'm going to go log base, I'm trying to find one here, 5. Here, let me go like base 4 of 16 equals. So what we got to do is figure out basically what this is equal to. Okay, so I'm going to put a little x there because I'm not sure. So I'm going to use the definition of a logarithm. There's my base. 4 to the x is equal to 16. Once I have that, I need to figure out what x is. Well, heck, 4 to the second, that is 16. So x is obviously going to be 2. All right. Now, some of these are a little bit tricky. All right, they mess with you some. So log of 1/2 of, say, 32 is equal to, I don't know, let's go x. So what does that mean? Well, we'd have 1/2 to the x is equal to 32. How does that work? Well, remember that when you have something like this, we know this 2, and this is a power of 2, so it would be nice if we can get them to be kind of the same thing. So in other words, now that I have a 2 there and a 2 here, I'm getting closer to figuring out what x is. If I could somehow get this 2 to go to the bottom, like this one is, then I'd be in good shape. I can do that by simply making that 5 a negative number. Because the negative exponent, remember, takes that and flips it or puts 1 over it. Well, now, these two things are the same. So my x turns out to be negative 5. And that's what that looks like. And so there's a couple problems kind of like that. You'll get a chance to work on them in class, obviously, before we take our quiz. So we play with them a little bit and ask questions of each other to see how you're doing on them. All right. I'm just looking at some other things in here and see if there's anything else that we need to know. They have a couple of problems where we're solving for x, and they go log of 5, or excuse me, log of x base 5 is equal to 3. Well, to get that answer, we can write as an exponent. Okay, use this definition of logarithm all the time. So we're going to take that base, there's my input, and what does that equal? Because that's what x is. All right, so that power, that's my, now becomes my input, that becomes my output. So anytime I have a situation where I need to solve for a logarithm, that's what I'm going to do. All right, I'm just going to use this definition of a logarithm to see what's going on. So let's do 6. Let's try one like that. So let's go 1, 2, 9, 6 equals x. Not sure what that is. Now, the ones in the book are all going to work out. They got to be powers of these numbers. All right, so we can think about this. Well, 6 to the second, that's 36. That's no good. 6 to the third. Well, let's see if we need 6 to the third. So let's go 6. Oops. So I think I have 6 to the third equals 216. Ah, well, not quite. Let's try 6 to the fourth. See what that looks like. 6 to the fourth enters. There it is. So then the x has to be 4. But see, you can do all these with the definition of a logarithm. Now, in actuality, you could do this in Desmos too. So you could go into here. Okay, let's clear some of this stuff out because I don't need it anymore. Oops, I could come down here and go, okay, how do I do that? We have this log A key, all right, where it's going to tell you to put the base in, so that's 6. And then we tap in here, and was it 1296, I think it was? And it's 4. All right, so Desmos will also allow you to put in a base that's different than 10. Okay. I forgot to mention that when you have a base of 10, that's called a common logarithm. All right, so I should have mentioned that. Base 10 log is a common logarithm. Okay, anything base 10 is common. So that's pretty much everything about that first section of on 4.4 on logarithms. We'll go ahead and pause this, and we'll do the next one.